Good day everyone, this is Vlad Kustov again with new video about covariant tensor machine. Today I tell you about how CTM perceives momentum vector in pseudo-Euclidean space or relativistic momentum. For beginning, I am searching a structure of momentum vector in pseudo-Euclidean space. Momentum vector can be represented as direct product invariant of velocity vector by scalar inertial mass. In classical mechanics of Newton, it's rectangle. However, in a relativistic case, I can represent it as a space of functional. In other words, vector of momentum consists of two vectors that lay on the same straight line. First vector is the velocity, and second vector is inertial mass. Inertial mass is a scalar quantity. It doesn't have direction. What is the rule that allows me to suppose it? Straight answer is reason of pseudo-Euclidean space. That space has a limit of velocity invariant and lives by moment of time, where each point has its own axle of time. All axles have the same direction of time between each other. I showed you graphically from past video that transformation could not change the direction of time. All one could do to receive time dilation. In addition, each point has the same velocity invariant. This is the speed of light. In that way, mass separates from velocity as components are in momentum vector. For that reason, inertial mass becomes partly vector quantity. Based on it, a point has two absolute. First absolute, I give the name kinematic absolute. Second absolute, I name as dynamic absolute. About kinematic absolute, I told you earlier in past video, dynamic absolute is created by kinematic absolute. For that reason, inertial mass is partly vector quantity. Dynamic absolute reflects a restriction inertial mass and says about law conservation mass. If point lives without interaction other points, thus the circumstance creates rest momentum of inertial mass. It can be represented all vector, or the separate absolutes as kinematic and dynamic, as soon as point starts to interact with other points. In this case, it's PdJ. Here appears the question, how does interact velocity and mass? What is the actual velocity of point after the interaction? For answer the questions, necessary to remember about past video where I said that an addition of velocity is rotation of spacetime invariant S in pseudo-Euclidean spacetime. In this case, I built vector diagram of momentums. It's a communicative vector diagram that tells me about momentum law conservation. Pj is a sum of two vectors, Ptj and Pdej, but this diagram doesn't give the understanding to me about mass interaction. I don't know mass m and big M to sum up or not. Here I know about only mass law conservation. For a decision problem, necessary to separate velocity vector and mass from momentum as the whole. It does help with two absolutes, kinematic and dynamic. Kinematic absolute separates only velocities and dynamic only mass. Now I defined the actual velocity after the interaction. It's simple because I knew from past video about angle phi between two space-time vectors. In this case, I have perfectly elastic interaction. This is because dynamic absolute is circle. Be worth noting, transient process of mass entails have a function, but final is always circle. Not complicated algebraic action allows to search actual velocity Vd. Here can see graph analytical connection between two vectors Ptj and Pdej. B momentum Pdej ever so huge, actual velocity Vd can't bigger than speed of light. For equality, actual velocity and speed of light demands infinity invariant of Pdej. It's a comparison of actual velocity and inertial mass. Here, inertial mass is a relativistic value. It was in early version theory of relativity. However, if we look at Ptj, then inertial mass is the scalar quantity that doesn't change during transformation. On kinetic and dynamic diagram can see how momentum transforms Pdj into other momentum. Then they can be represented separate components. Pj decomposes mass velocity. Pj reflects a result of spacetime invariant as mass is in the spacetime. Making a long story short, the diagram shows the result of interaction inertial mass or attribute of mass. In this case, the attributes of mass are velocity, the spacetime invariant, momentum, time dilation. Here I have given the question about how to separate velocities interact. It's worthwhile to consider all of processes here happen in infinitesimal moment of time and a field interaction is zero. Here I have only velocity and inertial mass. Momentum is a functional combination of velocity and inertial mass. Now then limit of speed or speed of light divides into two parts. Besides, it happens in all space direction. Another side, current of time, has one direction and vector of current time has maximum invariant. Its proper time. I knew space-time invariant in CTM theory. It has only one invariant or length of vector. That is speed of light. Position of space-time invariant defines all kinematic characteristics in generalized coordinate. Then I give to negative quantity or minus sign of space-time invariant that lays lower than speed of light. In addition, I give to positive quantity or plus sign of space-time invariant that lays upper than speed of light. All spacetime invariants refer to point of spacetime transformation. In this case, it's vector field, and I have vector flux field. Then I have flux of spacetime invariants. Flux of spacetime invariants goes through point of transformation where every vector of spacetime invariant changes sign of quantity and maybe direction. Divergence of vector flux is zero. Besides, it concerns massless flux and mass flux. Massless flux concerns only kinematic absolute, and here number of vectors is equal in both parts. It means future and past part. Present isn't part, it's line that divides past from future. Its speed of light, if it means full invariant that goes to absolute, and actual speed of point if it means a projection of spacetime invariant to axis of generalized actual velocities. Also, it's right for cases of perfectly elastic impact, where invariant of momentum gives to other points. Here, invariant of momentum doesn't disappear or doesn't appear. I see only a changing of invariance. Another word, it's momentum law conservation. It was new that momentum invariant consists of mass and velocity. This thing gives a set of cases for a changing of invariant. In pseudo-Euclidean space, CTM gives a clear understanding about time and its characteristics like the past, the future, and the present. This is because it's a graphical reflection of vector flux. Another case, I have momentum flux that doesn't be equal. Invariants can appear and disappear in point of transformation. However, invariants can birth or die, then they transform into another scalar forms. It will known like energy. Energy is a scalar function that allows saving a vector invariance in other forms. They can be heat, gravity, electromagnetic, atomic, and other energy. Here I finish my conversation about momentum and divergence of spacetime. See my next video about development of CTM in Einstein theory of relativity. In my future video, I will show you graphical reflection of energy. I will generalize a definition of energy and inertial mass. Thank you for your attention. Remember that gravity is a cradle of humanity.